Hello everyone, welcome to Out of Spec Reviews. I'm Ryan, and tonight we've got the Toyota bZ4X. We've got the limited all-wheel drive, and we're going to be taking it on our road trip simulation test. It's our 10% challenge. Let me tell you a little bit about this Toyota and a little bit about our test. As I mentioned, this is the Toyota bZ4X. This is a 2024 model, and this is the limited all-wheel drive trim. Now, there are actually multiple batteries for this, and they're both pretty similar in size. They charge a little bit differently. About 72 kilowatt hours, 64 kilowatt hours usable. Not the biggest battery, and it is rated for 222 miles of range on the EPA cycle. So really not super impressive. We've also run it on our own range tests before, and it wasn't great. Additionally, this vehicle has something a little bit weird. Like I mentioned, this is the 2024 model, and it essentially has a DC fast charging limit. So you can only DC fast charge so much over a certain period of time. So it's very important not to do a ton of charging. If you were to do a lot of charging in a row, for example, if you took it on a road trip, the battery will go into a limp mode, essentially. It will only charge at like 50 or 60 kilowatts, very, very slow charging, and it just makes the whole road trip experience much more challenging. But that's not exactly what we're looking for right here. We want to see what this will do in the best case scenario. And we've done just that, just to make sure we have not DC fast charged this car in several days. It has only been AC charged, and the battery is hopefully very happy with that. Now, let's talk about this 10% challenge. It's essentially just a road trip simulation. How far can you go from 15 minutes of charging? So the first thing that we do with this is, of course, set the tires to the recommended pressures, and then I take the car and I drive it and I take it down to precisely 10% state of charge. On most cars, I will plug in this charger as a destination, so the vehicle will precondition. However, this vehicle does not have preconditioning, so in order to make sure the battery was in the right temperature range, I used an OBD reader and a little bit of yo-yoing, a technique of like flooring it and using regen to get heat into the battery. So the battery should be in a great temperature range for fast charging. So this is essentially a pretty realistic scenario. When you get to a charger, you probably will have your battery at a pretty good temperature for charging, and hopefully on a road trip you'll be able to get maximum charging speeds right when you plug in. So from there, we'll go ahead, plug in, and charge for 15 minutes. There is actually a little bit of a delay between when you plug in and when it actually starts charging. We call that the handshake time, and we record it separately. So you do have an actual 15 minutes of real charging. During those 15 minutes, I'll be in the car and I'll have the car on. And again, this is all simulating a road trip scenario. Oftentimes when you're on a road trip and you're at a charger, you'll be hanging out in your car. And of course, you'll have the climate control running to make sure that you're also comfortable. This is an important detail because the climate control uses basically the same resources to keep the battery at the right temperature as it would to keep the cabin at the right temperature. So by requesting the vehicle to keep the cabin at the right temperature, it puts extra stress on that system. That could affect charging. However, again, it's just a realistic road trip scenario. So we'll charge for 15 minutes, and after those 15 minutes are up, I'll go ahead and unplug. I'll head over onto the highway, which is just over there, and I'll do a nice gentle acceleration. We want to do these gentle accelerations in order to avoid any sorts of losses from the accelerating up to speed. And we're going to go up to 80 miles an hour. Now, this is faster than our range tests, which are at 70 miles an hour, and we did this deliberately. Oftentimes on road trips, you are going a little bit faster. There are plenty of states around the US that have speed limits that are 75, 80, potentially even higher. So we chose 80 miles an hour as a reasonable but fast speed for road tripping. The plan is to essentially go out and drive the car like you normally would, put everything in the eco range modes as much as you can, but we'll still, of course, use climate control like you would on a normal road trip. We'll stay on the highway, and once we've used approximately half of our replenished range, I'm going to go ahead and turn around. Typically, we would put this charger back in as a destination, and that would force the car to precondition. However, it won't make much of a difference here. I'll still be doing it, but there won't be the preconditioning. Regardless, what we're going to do is turn around once we've used half of the replenished range and just keep an eye on our state of charge. We'll keep on driving, maintaining 80 miles an hour, avoiding drafting and any other cars, and just keeping it at a nice steady speed. And keeping an eye on the state of charge, we'll be looking at it when it goes from 11% down to 10%. That's going to be our result. So the important detail is we're not getting off the highway. So we'll be on the highway when it goes from 11 to 10%. And that will be, again, our result. So we're all set up, ready to go. Let's go ahead and plug in and see how this charging session goes. I'm going to have to activate this with my phone, record the handshake time, and you'll join very shortly. There we go, it's slowly ramping up. Looks like 96, 97 kilowatts. I saw a peak of 100 kilowatts. It just went off of it, but that's apparently a very good result. I spoke with Kyle, and that's the fastest he's actually ever seen it. So, like I mentioned, this is the Toyota bZ4X all-wheel drive, and there are two different batteries for this car. The front-wheel drive ones have a slightly smaller battery, but it charges at up to 150 kilowatts. The all-wheel drive variants have a little bit larger battery, but it charges at only, as you see, about 100 kilowatts. It's considerably worse charging. And that's a huge bummer, since you would expect, the more expensive, more premium all-wheel drive to have the best of everything, but unfortunately, it just does not. You join me in the vehicle, and we're at 27% state of charge. It says 35 minutes to get to 80%. It's been about 7 minutes, just about halfway. We're still doing 97 kilowatts, so it's been pretty flat, but 11, not even 12 kilowatt hours is not very impressive. I wanted to discuss that charging limit that I discussed before. So this is a bit of a weird behavior for these Toyotas, and basically what happens is if you charge too much over a given period of time, it will severely limit your charging speeds. It used to be if you had about 2 full charging sessions over, I think, a rolling 24-hour period, it would really start to limit your charging speeds, and that was not great. There has been an update since then, and it is increased to 3 charging sessions, so a little bit better, but it's still kind of a really confusing strategy. I'm not sure why they would decide to do that, or what benefit it provides. It's just a huge inconvenience and really limits the usability and road trip ability of this vehicle. Regardless, this is still a best case scenario right here, right now, and 8 minutes, 30% state of charge, 31, wow. No, this is not too impressive, but it is what it is. It's hard to tell because it's going down extremely slowly, but I did see it go back to 100 kilowatts, and it is slowly crept down to 95. So I believe it started to taper, but there's not a whole lot to taper from. We're coming up on 15 minutes. You can see we are pulling 87 kilowatts at the moment. So yes, it has started to taper, but not a whole lot. Now let's get those results. got up to 45% and did 24.0 kilowatt hours. I can't tell from the top of my head, but that is one of, if not the lowest amounts of energy delivered in one of these tests. So pretty disappointing. It's actually indicating 46% here. So just to review, we've got auto eco. We're going to keep temperature between 68 and 72. We've got eco mode. And let's see, press and hold OK. We'll reset our trip average as well as the odometer. And good to go. Buckle up and we can get going. You join me barely a mile later, and I'm on the highway, accelerating nice and gently up to 80, and then we'll set the cruise control. And I double checked, and it turns out 81 miles per hour indicated is 80 miles per hour GPS speed. So that's where we'll be set. And now we can just hang out and cruise. As we saw, I got up to an indicated 46% state of charge, meaning I added 36%. Half of 36 is 18, meaning I should turn around when I've used about 18% state of charge, which would be 28%. So that'll be roughly the target that I'm aiming for. And unfortunately, we're already at 43 after just 3.7 miles. But we'll see how it goes on the round trip. It feels crazy, but it's about time to turn around. I'm at 30% state of charge. We've got Owl Canyon and then about like 7-ish miles to the next exit. So I think it makes sense to turn around here, and we can just go a little bit further than the charger if we have extra juice. So that'll be our plan. And of course, as we always do for these, while I'm slowing down, I'm using regenerative brakes and putting as much energy into the battery back as I possibly can. I'd like to get as far as I can, even if it's, only 50 miles or so. But regardless, using regenerative brakes to get as much energy back into the pack. And then when I turn around, I'm, of course, again going to do another acceleration, nice and gentle, back up to 80 miles per hour GPS speed. So 81 indicated. The moon looks pretty cool. A nice gentle acceleration up to 81 miles an hour, and I've dropped down to 29% state of charge. So I think it makes sense. I think that was a good call to turn around where I did, because it would have been too far to go to the next exit. But we are at 26 miles, and looks like we can go further than 50. So at least that. Something I'd like to mention is that, generally speaking, we refer to 100 miles an hour as a good benchmark. Anything that can do 100 miles in this 10% challenge is pretty good. We're looking to see if we can break 50 with this, so I think that gives you a bit of perspective on how this compares with other vehicles. While I'm here, I thought I'd give you a little bit of my opinions on this car. Now, I don't love it. I think that's a pretty common opinion. There's a lot of shortcomings on this car, especially when it comes to range, efficiency, and charging. However, there are some really great lease deals available right now for this. And if you can get a great deal, I think it makes sense as a second car. This is not something that you want to take on road trips, but it's perfectly adequate for around town doing whatever. It's got a solid infotainment system. It's got heated seats, heated steering wheel. Most of the materials are pretty solid. Everything's acceptable. It's reasonably comfortable. The seats are fine. I think, generally speaking, everything's fine. It's fine. And I think that's okay for some cars. I don't think every car needs to blow everyone out of the water. Sometimes you just need a car. And I think that this vehicle will accomplish that. Whether it's the best option, I think will depend on what kind of deals you're able to get for this. So hopefully you can get a great deal on this, but I think it's important to acknowledge that there are a lot of shortcomings, especially when it comes to the powertrain for this. Okay, I just passed our exit for the charger. We're going to keep going since we still have 14%. And we also passed 50 miles a moment ago. So I guess that's a benchmark, I suppose. I don't know. It's better than 20 miles. Regardless, we'll keep an eye on the state of charge and see how far we can get when we go over from 11% down to 10. And there it is, 10% state of charge. We went 58 miles. That is not a great result. Yeah, it says we got an indicated 2.7 miles per kilowatt hour, which is also nothing too impressive. But it's not terrible, especially for like a crossover SUV type vehicle. So let's take a moment and do some data analysis and see how this compares with some other vehicles in this class. Look, there's just no two ways about this. This was a poor performance. This 10% challenge requires both good charging as well as good efficiency in order to do well. And unfortunately, this Toyota bZ4X came up short in both of those categories. Charging was very poor. A peak of 100 kilowatts is very low, and we only delivered 24.0 kilowatt hours. The only vehicle that delivered less energy was the new Fiat 500, which is very much a city car and not designed for road trips in any way. In fact, the Fiat 500 actually was very close in its overall performance in this 10% challenge. However, let's go back to the charging. That 24.0 kilowatt hours is worse than a Tesla Model Y 4680, which had 25 kilowatt hours. Worse than the standard range Volkswagen ID4 at 26.2 kilowatt hours, worse than a Volkswagen VF8 at 29.4 kilowatt hours. We often rag on all three of those cars for very poor charging, and the bZ4X was even worse. I think the worst part is that this was an absolute best case scenario. As I briefly discussed, there is that charging limit, and if you charge too much over that period of time, it will severely limit your charging speed, so it will be considerably worse than it already is. And really, that's borderline unusable, unfortunately. Next, let's talk about efficiency, which unfortunately wasn't much better. For these tests, we usually calculate efficiency by dividing miles driven by energy delivered. Here, the bZ4X had 2.4 miles per kilowatt hour. It's better than a VinFast VF8 at 2.2, better than a standard range Volkswagen ID4 at 2.3 miles per kilowatt hour. This is about similar to a Polestar 2 performance, but it lags quite a bit behind some of the more efficient crossovers such as the EV6, which had 2.7 miles per kilowatt hour, or the Model Y, which achieved 2.9 miles per kilowatt hour. Of course, combining some of the worst charging we've ever seen with poor efficiency leads to a poor result on our 10% challenge, only 58 miles. This is a really poor result, but I think it would be unfair to say that the bZ4X is alone right here. Like I mentioned before, the new Fiat 500 was pretty close. It had 56 miles, which is worse. Then again, the new Fiat 500 is designed specifically to be a city car. Road trips were never in mind, so maybe it's not too impressive that the bZ4X beat it. Still, the standard range ID4 at 60 miles, VinFast VF8 at 66 miles, and RZ450E at 68 miles all show that it's not completely alone in this poor performance. Notably, the VinFast and Lexus are considerably more expensive. That's before you would factor in any sorts of discounts, incentives, all that stuff that's, of course, going on right now. Unfortunately, right now, the Toyota bZ4X occupies two of the bottom three spots in our 10% challenge, joined by the Fiat 500e, a city car. Yes, it's true, the bZ4X is not alone in this poor performance, but it doesn't take away from the fact that it's really quite disappointing and severely limits the usability of this vehicle. I really don't like ending on such a negative note, so I would like to mention that at least right now there are very good incentives going on, so you could probably find a lease deal for a very reasonable amount of money for one of these. And if you're not taking it on any road trips ever, I suppose it's okay. It's an alright vehicle. Well, thank you so much for watching. We'll see you on the next one.